The importance of knowing your identities is to solve equations. And the best way to do that is to start solving equations and see why this is important. Now, at this point, to algebraically solve this question is a lot of work, or impossible, okay, the way it is. So the whole thing that you've got to be doing is get the equation so it's all sine x, sine x, sine x, or cos x, all the way through, okay? That can be done using identities, okay? Now, the thing to look at is how are you going to decide how to get this so they're all sines or all coses. Now, again, through experience, you get good at these, but you go, 3 sine x, how can I turn that into cos x? Okay, you probably are looking at the whole thing and going, how am I supposed to switch anything to sine or cos x? But this is kind of the money right here. See, cos squared x is that easiest of all the identities, and that's the trig identity, or the Pythagorean identity of sine squared plus cos squared equals 1. But cos squared, if you look at your formula sheet, is sine squared, or 1 minus sine squared. So I am going to take this and make it 2 times 1 minus sine squared x, and then the rest of the equation, 3 sine x equals 0. See, now I'm dealing totally in sines. You want to multiply that 2 in to get 2 minus 2 sine x, sine squared x, plus 3 sine x equals 0. Okay? Now I'm just going to get it in order of degree, negative 2 sine squared x plus 3 sine x plus 2 equals 0. And I'm even going to multiply it all by negative 1 because I like this to be positive. Okay, so just multiply by negative 1. So now this is positive. So basically, after this step right here, we are doing review. We have done these before. Now, we are we are going to be looking for 2 things that add to give me negative 3 and multiply to give me negative 4, right? You have to multiply the a. And those 2 numbers are negative 3, negative 1. So 2 sine. Yeah, that's right. Negative 4 and 1. So 2 sine squared x minus 4 sine x plus 1 sine x minus 2 equals 0. Put our brackets around this one, brackets around this one. I can take out a 2 sine x, leaving me with sine x minus 2. And I will take out a 1, leaving me with sine x minus 2. So that's sine x minus 2 times 2 sine x plus 1 equals 0. Now, remember, we're doing when sine x minus 2 equals 0, or when sine x equals 2. Does sine x ever equal 2? No solution. On the other side, we're doing 2 sine x plus 1 equals 0. Minus 1 to both sides, divided by 2 when sine x equals negative 1/2. When does sine x equal negative 1/2? Which quadrants? 3 and 4. And 1/2 is, what is the reference of 1/2? 5/6. Okay, so the answer would be pi plus pi, so 7 pi over 6 and 11 pi over 6. Okay. Now B. The thing about B is that you want to go, this one, you're going to go look at your identities, and is there a cos something minus cos something in your identities? What are we going to do here? Is there a cos A plus B identity? So this could be the cos A plus B identity minus the cos A minus B identity. There's 2 identities in this one. Okay? So if it's a plus sign, I'm going to go to that equation. And that would be cos x cos pi over 6. Because this is A and B. This is A and B. And then it's minus sine x sine pi over 6. And then there's a big minus sign from here. I'm going to do the second identity. This is A and this is B. I'm doing cos A minus B. So that's cos A, cos x, cos B, cos pi over 6, plus, right, for the minus identity it's plus, sine A, sine x, sine B is pi over 6, and that all equals 1. Now we can simplify this, because if you take this, what's cos pi over 6? Root 3 over 2. So this would be root 3 over 2 cos x. Okay, the number always goes first. But I can't solve cos x, but I can solve root 3 over 2. Okay, minus, what is sine pi over 6? 1/2. That would be 1/2 sine x. Minus, bracket. Okay, same thing, but that's going to be root 3 over 2 cos x plus 1/2 sine x equals 1. Am I making sense so far? Now, this negative, don't forget, it has to go into both. But do you see root 3 over 2 cos x minus root 3 over 2 cos x? Gone. Okay? Negative 1/2 x, half sine x, minus negative 1/2 sine x. Negative 1/2 plus negative 1/2 is negative 1 sine x equals 1. Divide by -1. When does sine x equal 1? Happens at, or -1, sorry. Right, 1 divided by -1 is -1. That happens right here. So what does x equal? 3/2. Okay. Okay, now this one says consider this equation. 4 minus 7 sine x cos 2x. And then it wants the general equation. General means to keep it going and going and going. Now, first question that I would ask, who would you get rid of here? The sines or the coses to get them all the same? The cos 2x, right? Now you have 3 things to pick from. What's the only one that would not still give you cos x's? Because that's a waste of time. 1 minus 2 sine squared, right? So this is going to get replaced. So it's 4 minus 7 sine x equals 1 minus 2 sine squared x. Now let's get it to equal 0. Let's get everything to the right. So if I do that, here's my equal sign, right? If I do that, that would be 2 sine squared x minus 7 sine x. And that 1's going to come over to be a -1. So it's going to take away 1 from that 4. Okay, so back to grade 10. What 2 things add to give me -7, multiply to give me 6. -6, -1. 2 sine squared x minus 6 sine x minus 1 sine x plus 3 equals 0. Brackets around that one, brackets around that one. I will take out a 2 sine x. It's going to leave me with sine x minus 3. I'll take out a -1. That'll leave me with sine x minus 3 equals 0. Okay, so that's sine x minus 3 times 2 sine x minus 1 equals 0. Squiggly line, no solution, because sine x equals 3. There's nothing to do. This would be, I'm going to have to go 2 sine x minus 1 equals 0. Add 1 to both sides. Divide by 2, sine x equals 1/2. When does sine x equal 1/2? Pi over 6. For reference in, right, because this is a and s. Now we're doing general solution. So the first solution is pi over 6. Now, can I get the next one by adding a period to it? No. So you're going to have to do that one separately. And it's in the integers, and x equals pi over 6 plus 2 pi n, and is in the integers. Pi over 6, yeah. Okay. Now the next 2 pages are all about when you divide by cos x. And it works too when you divide by sin x. But if you're dividing by cos x, there's a possibility you may be dividing by 0. If x equals pi over 2. Okay? Plus n pi. So if you ever divide, which I recommend never doing, always subtract to get it all on one side. Don't divide, because if you get an answer, pi over 2, then there is no answer. Because if the answer is pi over 2, that would make me having to divide by cos pi over 2, which is divided by 0. So the next 2 pages are just doing that. They're just trying to tell you that. So if we go down to the bottom, under what circumstances is division by cos x not valid? And that's, I would say, if x equals pi over 2. You can't divide by 0. Okay, and we've done that. We've done non-permissibles. I know what you're saying. You're going, but there was coses on the bottom. If it's in the question, if you're doing it to solve it, you can't do illegal things to solve an equation and expect to get the right answer. Okay? So that's all what that's about, is always be careful. Some people want to always divide. Just subtract to get it all on one side. Now, let's if I do this. Yeah, I think I did this with the other class. Let's go to the next page. Okay, so, and again, it just kind of stresses this. If pi over 2 is the solution to either equation, then the step in which the student divides by cos x is not valid because she is dividing by 0. You can't divide by 0. Okay, yeah, and I'm not going to go through. Okay, let's go to the next page just so we can do these 2 questions. Now, question number CI. We're going to do this question. It says, use your graphing calculator to solve this. And I actually want to do that with you, because some of you, that's probably the biggest question I get when I'm walking around, is how do you do this in a calculator? Now, I'll just clear this. This is what we're going to put into the calculator. 3 sine. Now, how am I supposed to square this? Well, you want to put a bracket before the sine, then hit sine x. You close that bracket, then close the other bracket. That's saying I want to square all of sine x. I don't want to square the 3. It's not squared. Plus cos 2x minus 2. Now if you see the domain, it's between 0 and 2 pi. So in my windows, I'll put 0, and then I will put 2 pi. And then when you hit the down button, it changes to decimal for you. Okay? And my scale is going to be pi over 6. So I just go pi divided by 6. And when you press down, you change it to decimal. The other thing, my max and min, -2, -3, around there to 3, and my scale is 1. Now when you graph that,
please excuse the interruption. The 30-hour famine has now begun, and you may not eat any food from this time until 5 p.m. tomorrow. Remember to keep yourself hydrated by drinking lots of water and clear juice. Have a great day.
the apple juice is cheating quite a bit though. No. I know, but apple juice is full of sugar. Okay. Now, I don't know. You could live off Gatorade. I have lived off Gatorade. Yeah. I was building a deck one summer. I didn't have time to eat, so I just kept drinking Gatorade. Just about. No, I didn't. I was on fire. Okay. I don't know how that's going to be that good a commercial, though. Now, if you see, these are all pi over 6. So it's 1, 2, 3 pi over 6, which is pi over 2, 4, 5, 7, 8, 9 pi over 6, which is 3 pi over 2. Okay? So when you're in trig and it bounces, there's only one answer. Remember when we were solving before? A bounce meant 2, a squiggle meant 3. In trig, a bounce is just one answer. Okay, so you want to just take a rough sketch of that and get it down. And we will say our answers are 3 pi over 6, which is pi over 2, and 9 pi over 6, which is 3 pi over 2. Now, whenever faced with a written response question, I know it sounds counter-timely to go and do this before you even start the question. But you can actually save a lot of time, because if you know what the answer is, you can make sure you're leading there as you're doing it. You'll know there's a point where I'm not going to get that. Okay, so then you haven't done all the other steps, and then you're going to go graph it and go, okay, that sucks. I don't have the right answer. Okay? It's kind of like, I don't know if you've ever, been looking for a house or you're looking for an address or whatever, and then you go to Street View and you see exactly what the house looks like. It's got brick there, whatever. Then when you're going, you don't even have to look at the address as much as you just recognize the house. Okay? So it does help you save time in the end. Now, let's do this one algebraically. Okay, let's just write it out again. 3 sine squared x plus cos 2x minus 2 equals 0. Now, remember rule number 1. If it's not all sine x or all cos x, you can't go on. There's 2 ways you could go with this one, because sine squared x has a nice substitution and cos 2x has a nice substitution. I'm going to stick with all sine x again. Okay? So I need to get rid of this, and I'm going to look at my identities again. Cos 2x is, because there's only one I can pick that doesn't have cos in it again. And if your objective is to get rid of cos, the other 2 are not going to help you with that. So I'm going to replace that with 1 minus sine squared a. So this is 3 sine squared x plus 1 minus 2 sine squared x minus 2 equals 0. Now this one has a simplicity to it after that step that makes this a good question, because if you don't see that one step, you're in for doing a lot of work, right? And taking time. to get the wrong answer. So I actually have a 3 sine squared x minus a 2 sine squared x. So then I would be left with 1 sine squared x, and then plus positive 1 minus 2 is minus 1 equals 0. Okay, then I have sine squared x equals 1. Here is where this was a diploma question. We'd lose a lot of the province on this one, because I have to take the square root of both sides. Sine x would equal plus or minus 1. You can see how obviously this is going to be a deal breaker. Yep. Yep. So what Kevin's saying is you could have done this as sine x minus 1, sine x plus 1 equals 0, and you'll get when sine x equals 1 and when sine x equals negative 1. So I don't know if we saved more time because I have sine x equals 1 or negative 1. Maybe. Yeah. Okay, but if you're going through the diploma second time through, do it a different way. Okay? You did the difference of squares? Yeah. Well, at least it shows they're both right. Okay? They both will get there. Hopefully we're not on our phones right now. Okay. When does sine x equal positive or negative 1? Pi over 2, oops. And 3 pi over 2, right? Okay. Let's just do one more together. So we're, what if I took, let's do this one. This one is a good one because some of us want to jump right to going, okay, Mr. Trimble said you can't have sine and cos in the equation, so I'm going to get rid of one of them. But what's nice about this one is, are those two things are multiplying together. If they're multiplying together, they're already factors. When they're adding together, like in the one before that, and the one before that, and the one before that, then you've got to get everything sine x or cos x, so you can do your factoring, type 1 or type 2. But this one is done for us. So it's when negative cos 2x equals 0, and when 3 sine squared x minus 2 equals 0. So that's the first kind of quirk on this one. The next one is a review of an entire objective. So I can obviously multiply that by negative 1, and that's cos 2x equals 0. Now, we don't know when cos 2x equals 0, but when does cos x equal 0? Pi over 2 and 3 pi over 2. Now cos 2x, a horizontal stretch by 1/2. So if we take this graph, and we do a horizontal stretch by 1/2, first of all, how many answers will I have? I'll have 4 answers. What's the first answer if I do a horizontal stretch by 1/2? pi over 4. The second one, 3 pi over 2. Oh, 3 pi over 4, I mean. Okay? How do you find the other two? You add the period, which is 2 pi over. Period is 2 pi over b, which is 2, so it's pi. Pi, because we want a common denominator, is 4 pi over 4. That would make that 5 pi over 4. 3 pi over 4 plus 4 pi over 4 is 7 pi over 4. Okay, that's just for the one side. For the other side, it is going to be when is sine squared x equal to, if I add 2 to both sides and then divide by 3, then I will go when is sine x equal to plus or minus root 2 over 3. Now, that's not on the unit circle. At least I hope you know it's not. But this is where, if you read this, except find exact values where possible, otherwise round the answers to the nearest tenth. So we're going to do this like we learned in the one objective. The first thing we do is find the reference angles. Okay, what is the reference angle? So you go second sine, the absolute value. And we'll go to like 3 decimal places. What did you get? So reference angle 0.95. It's almost 1 radian. Now, where is sine positive and negative? In all 4 quadrants. So we're like there, 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 and there. So the first angle to the nearest tenth would be 0.1. Or, no, sorry, 1.0. 0.955, that rounds up. So that's the first one. How would I find the second one? Pi minus 0.955. Don't use the 1, because you rounded that for the answer. Okay, and that would be 2.2. The next one would be pi plus 0.955, and that's 4.1. And the last one would be 2 pi minus 0.955, which is 5.3. So the answers to that question, if you graphed it, you would see all of these: pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 1.0, 2.2, 4.1, and 5.3. Okay, so we'll do 1 to 8, A, C, E, G, dot, 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 and 9 and 10. Okay, it's got a healthy amount of time. The last 10 minutes, we'll get your test back to you.